Okay, so what we've got now, and again, we talked about it a little bit yesterday when we were talking about the reciprocal functions. Here's where we're going to dig into it a little bit more because yesterday all the graphs were pretty straightforward, pretty basic. This one we're going to dig into a little bit more. We're still talking about vertical and horizontal asymptotes. Now, here's the big difference today. We're talking about more complex um, fractions or rational functions is what they call it. Rational just meaning that's fractions. Um, but for these, here's what we got to have. And this is kind of like your checklist because this was easier just to make sure everybody had this part. For vertical asymptotes, define any vertical asymptotes for anything we're going to do. You just take your denominator and you set it equal to 0. All right, now here's where we're going to add in one extra thing with this one. If you can factor something from the numerator and denominator, which is kind of going to the next part of it, it creates a hole in the graph. Basically, there's a number that you're kind of leaving out as you go through this thing. So sometimes you may call that what you're doing. Now, in Math Excel, when they talk about the denominator equal to 0, they call that points of discontinuity. Okay, so when you're seeing that in Math Excel, sometimes they'll talk about points of discontinuity. Um, that's basically what they're saying. It's still anything in the denominator equal to 0 because that could include the asymptotes, but it also could include the holes that you've got that's here. And if it's a hole in the graph, when they talk about these, when you're talking about Math Excel, that basically means that it's removable. Because again, basically, if it's something that you canceled out of the numerator and the denominator, then you've done exactly that. You've removed it out of the question. So that's what they're saying is going to make it removable. Okay, so vertical asymptotes is your denominator equal to 0. That's your points of discontinuity. Hopefully I'm saying that correctly. And again, if it's a hole where you can factor something out, that's a removable point of discontinuity. If it doesn't factor out, then it stays. It's non-removable if it comes off that point. Okay, horizontal asymptotes. Now, before it was just when we did it yesterday, horizontal asymptotes were y equals 0 as we were going through that one. And this one today, it's not quite as cut and dry. Basically, it's a situation where depending on what your equation is or what your fractions are, it's going to be this one. So you've got to figure out what the degree of your numerator is, which we're going to call m, and the degree of your denominator, which we're going to call n. And then you actually have to compare the different degrees. If your degree of your numerator is less than the degree of the denominator, you've got a default one at y equals 0. So it's the same thing as we were doing yesterday. Okay. And if you think about what we did yesterday, we were doing like 4 over x minus 2 or something like that. So it kind of fell into that same category. Now, if the two things are equal, you've got a horizontal asymptote at, and basically it's the term, it's the coefficient or the term of the m variable we're looking at in the term of the n. So basically it's just factoring out the two coefficients. So it might be y equals -2, might be y equals 4, could be a half, something like that. And then, and the good news that y'all would hope is going to happen, which is not going to happen, other than just a question of seeing if you got one. If the numerator has a greater degree than the denominator, there is no horizontal asymptote. You actually get what you call a slant asymptote, which means instead of having a line that's vertical and horizontal line, if this was our horizontal asymptote going this way, it's going to start to tilt like this. That's why they call it a slant asymptote, which means and to find that one, which we're not going to do, if you need to find the slant asymptote, you have to do synthetic division. Yeah. So that part of it, we'll worry about that another day. And you'll actually kind of get to that more really next year because we've talked about doing synthetic division, and that's where it would actually tie in with some of the things that we're going for these. Okay, so here's what we're going to do. We're going to take these few problems, and before we do any graphs at all, we're just going to find the horizontal and vertical asymptotes if they exist. Because again, sometimes it may be that they may not exist just because of the way the numbers set up for this thing. All right, so for this one, vertical asymptotes. And again, vertical asymptotes, that is your denominator equal to 0. All right, so that was pretty easy. That's just x minus 5 equal to 0. There you go. So you've got a vertical asymptote at x equals 5. All right, for your horizontal asymptote, Again, it's one of those you have to find out the comparison on these. So if you're looking at your leading terms in this case, you've got negative 2x, and all you really need is your highest powers, your degrees. So in this case, it's x to the first on top and x to the first on the bottom. So basically, you pull out your leading terms if it's in descending order. And in this case, your numerator is degree 1, denominator is also degree 1. So if these two things are the same degree, then it says, all right, for number 2 option here, if these two things are equal, if your degrees are equal in numerator and denominator, then the horizontal asymptote is y equals 2. And basically, you just cancel out these x's back here. So if you cancel out your powers, because they're the same power, so they're going to cancel each other out, that's going to leave you at y equals negative 2 over basically 1. So that's just y equals negative 2. Okay, so if I ask you just to find the different vertical and horizontal asymptotes, that would be it. Now, one thing they may ask you after you do the vertical asymptote, they may ask you, is x equals 5, is it removable? Meaning, could you factor that out in the beginning back here? No, right? Because the only now you could factor a negative 2 out, make that x minus 3, but that's still not going to cancel the x minus 5. So they ask you, is this thing removable? Then we'd tell you, no, it's not removable. It will not factor out. Okay, I couldn't see that. So if we factored it out over here, it would look like that. But again, those two things won't cancel out because, again, you've got to realize that when you've got this denominator, you've got to think about that being in parentheses. That you got to have exactly the same thing, numerator, denominator, to cancel. Okay, so let's do number 2. All right, so for that one, we got a vertical asymptotes. Again, denominator equal to 0. All right, kind of good review because now you have to do some factoring. What are the factors of negative 12 that equal positive 1? Got to be 3 and 4, right? Your b term is positive, so the bigger number needs to be positive. So if we divide a negative 12 and a positive 4, that makes that a negative 3. So if we factor out that denominator, we've got that. Setting each one of these equal to 0, we're just going to change those signs so we get x equals 3, and then x equals negative 4. All right, now we've got, so basically what we've got to think about here is when we've got this thing, we've got this is x minus 3 over x minus 3 and x plus 4, right? So if we factor out the original equation, we've got this. These two things would cancel. So technically, this x equals 4 is your vertical asymptote. And because we could cancel this out, x equals 3 winds up being a hole. And you literally have a hole in the graph. When we graph some of these, you'll actually see, you may see a line going through, and then you'll see a hole, and then the graph carries on like that. Or it may be a graph where it's more like this. But again, you may actually have just a hole in the graph as you're going through this thing. Okay, so go ahead and factor out your denominator, and then again, take it back to the original. And again, if you can cancel, that makes it a hole, which again, they're calling that removable sometimes. If it doesn't factor out, then it's your vertical asymptote, which means it's a non-removable point. Okay, and then horizontal asymptotes. Numerator is degree 1. Denominator is degree 2. Okay, and it's always, notice over here, the m is always first, so you always have to put your m value first. So in this case, you need m compared to n. That's 1 and 2. Well, 1's less than 2, right? So m is less than n, which means by default, this thing is going to have a horizontal asymptote at y equals 0. Okay, so vertical asymptotes, again, goes back to the denominator, setting that equal to 0. Horizontal asymptotes, you've got to compare the degree of the numerator, degree of the denominator, and how those two things compare. It's going to tell you what kind of asymptote you're going to have there. All right, let's do a couple more of these, and then we'll actually get some graphs and see what the graphs look like. All right, so again, vertical asymptotes, that's just x minus 4 equals 0. So that's x equals 4. Okay, and if we, now there's nothing in the bottom we can factor out, but could we factor out the top part on that one? I think it would be this, right? Okay, so again, we know nothing's going to cancel, so that's not a remove. That's not a hole in the graph. That's nothing that we can do for that part. So that one's just straight up a vertical asymptote. Okay, for horizontal asymptotes, numerator is degree 2, denominator is degree 1, and again, m needs to be first. In that case, the m is greater than n because 2 is greater than 1. And if it's greater, this is where y'all kind of go, yay, that there's no horizontal asymptote. That's a slant asymptote. Now, again, if you're in pre-cal, then you actually go in and find that slant asymptote and figure out where it's going to be. But for this part of it, we're just going to say, all right, there's not one there. We know it's going to be a slant asymptote, but we're not going to worry about it. We'll just kind of move on. Okay, one more, and then we'll actually start graphing these. Too far. All right, and you may get to the point where on some of these, you may actually want to just go ahead and start factoring everything out before you do anything at all. So for this one, it's x minus 6 on top. We can factor out an x and make it x times x plus 5. But again, there's still nothing that cancels in this thing. So now it does make it a little bit easier because for the vertical asymptotes, it's x times x plus 5 equals 0. Well, that's x equals 0. X plus 5 equals 0. So then we've got two vertical asymptotes, one at 0 and then one at negative 5. Okay, again, nothing cancels. So we've got two vertical asymptotes in this case. All right, and then for horizontal asymptotes, the numerator is degree 1, denominator is degree 2. Again, we got to compare m and n. That's a 1 and a 2. 1 is less than 2, so m is less than n. And again, and if m is less than n, we can go back and look and see, then by that part, it defaults back to y equals 0. Okay, so there's the basics on everything that's here. Now, if they happen to talk about domain and range, domain and range is going to come from your vertical asymptote. So basically, because again, you're going to skip over these 2 points. So domain and range is going to be it's negative infinity to infinity, but you're going to skip over these 2 points. So if they talk about the range, again, they're kind of back over here to this part of where you got your horizontal asymptotes. But there's where you're going to have your holes in your graph, your missing parts. So it'll be negative infinity to 0. Sorry, negative infinity to negative 5, negative 5 to 0, and then 0 to infinity. Because of how they've got these things set up. So it's basically the same thing as yesterday's what we're doing. All right, now let's actually sketch a graph so you can kind of see what's going on with this one. If you want to do this on the back, you can. I'm going to do this on like a separate piece of paper just so that I do better with the lines to kind of keep everything straight. Okay, so we've got y equals 2x plus 3 over x minus 5. Okay, so we're going to find the horizontal asymptotes, the vertical asymptotes. We're going to sketch the graph. And we may throw in just, for a bonus, we may throw in some domain range on this one just to see what we've got. Okay, nothing cancels. So that part of it, there's no holes in the graph because there's nothing that will cancel off on this one. So vertical asymptotes, that's just x minus 5 equals 0. So it's x equals 5. All right, and that kind of goes into the same thing we were doing yesterday, that if this was 3 over x minus 5, we knew that we were going to move this thing 5 spaces to the right. So that's the same thing we were doing yesterday, that if it's just this denominator, we're going to move it to the right. There's our numbers we're looking for. Okay, for the horizontal asymptote, this one has the numerator of degree 1, denominator also degree 1. In that case, your m and n are both 1, so m equals n. So for this one, that's where it's going to basically, if we go back and do that, and again, cancel those two numbers out, or cancel out our two x's here, it's going to leave us at y equals 2. So we've got a horizontal asymptote at y equals 2. Okay, and then when you go to graph it, now we know that basically yesterday when we were going through these, we know that the center is not going to be at 0, 0, that we've got a horizontal asymptote at 2, we've got a vertical asymptote at 5. So basically the center of this graph now is kind of moved over so that we've got a asymptote going this way at x equals 5. We've got another one going this way. So we've kind of shifted the graph, the center of the graph from 0, 0 over to 5, 2. Okay, now, and yesterday, we knew that if this thing was 3 over x minus 5, we had a nice shortcut that we could take this graph and we could go back and go, oh, well, if that was just 3 over x minus 5, we knew that was a positive 3. We could draw the graph here, we could draw the graph here, and everything was great and good and wonderful. But here's the problem we've run into with this one a little bit today, is it's not just 3, but it's 2x plus 3 over x minus 5. So that extra variable kind of throws things off a little bit. So what you're going to have to do is, for this part of it, and this is where it kind of takes a little bit of work to get through these. So to find the graph, you're going to have to plug in again, the fancy word for plugging in is evaluate. A value for x on both sides of every vertical asymptote. To see where the graph goes. Because again, we said these were basically like fences, that if you're going through these, that sometimes with this part, that if basically it comes down to the right side of the graph is either going to be up here or it could be down here. The left side of the graph could be here, but also could be here. And because of the extra variables involved, we don't automatically know where this thing is going to be. So we're just going to have to plug in some test values and see where this thing is going to go. Because if we plug in, I always say keep it really close here. So if we plug in x equals 6, which is this point, it's either going to be somewhere up here or it's going to be somewhere down here. It's got to be on one side of the fence. People tell you that you can't be on both sides of the fence. Same thing in this one. If you're going through these, you can't be on both sides of the fence unless there's a gate, right? If there's a gate in your fence, you can be on both sides at the same time. You can put one foot on one side and you put one foot on the other. So sometimes that does happen with some of these graphs. I don't know if we'll see one exactly, but sometimes you may actually have a hole that's on one of these asymptotes, and you can actually go from this side of the fence over to this side of the fence. So, okay, so here's what we're going to do. We're going to plug in x equals 6, and we're going to plug it back into the original function and see what we get. Oh, that we need to pick a number on either side of the vertical asymptotes. So if x equals 5 is our vertical asymptote, I'm just going to pick the next number right beside it, x equals 6. And then we'll do the same thing on the left side. We're going to come back and plug in x equals -4 and see what, or sorry, not -4. We're going to plug in 4 and see what happens on that side. All right, so take the 6 and plug it back in. 6 will go there, and 6 will go there. So that'll leave us with 2 times 6 is 12. 6 minus 5 is 1. So that's 12 plus 5. That's 15 over 1. So that y value is just at 15. Okay, so that ordered pair is at 6, 15. Okay, so on this graph, we know that we know for sure that 615 is on this graph somewhere. So if we plot that point, 615 would be somewhere way up here. So that just lets us know that, okay, once you've put, it's kind of like, I hate to go back to the, cows, but if you've got cows and you got fences, once you put the cow in here, that cow is going to stay in here. So all those points are going to stay in here somewhere. Okay. And then we'll do the same thing with x equals 4 to figure out whether it's going to be in this section or whether it's going to be in this section. So again, we'll plug in 4 here and plug in 4 here. So it leaves us with 2 times 4 is 8. Plus 3 is 11. Oh, sorry, can't see it too well. Plug in 4 here. That's 4 minus 5. That's -1. So that's 11 over -1, which is -11. Okay. And again, all you need is 1 point. Once you've got 1 point, you know where all the other points have to be, because again, it's like a fence. It's going to keep everything in that particular area. So that point at 4, -11 is going to be somewhere way down here. So that means that all these points here are going to have to look something kind of like that. Okay. And again, it doesn't have to be a perfect graph, because y'all will have to sketch. There may be a few of these graphs you're going to have to sketch by hand on the test. And they don't have to be perfect. They just need to be close enough to perfect. As long as you're close. All right. Everybody okay with that one? Again, big difference is today it's not just, oh, okay, we know that this thing is here and here. Again, it could be that you may have it here and here. It could be here and here. It could be that you got one here and here. So there's basically, you just don't really know. But you do know that on the left side, it's either up here or down here. And on the right side, same thing. It's either up here or down here. And we just need 1 point to know where that graph is going to be. All right, now we'll give you one with a little more fun to it. It may just show you one that's got a hole in it because we may run out of time. We'll see. All right, example 2. We'll do the same thing. We'll go with x minus 2 over x squared plus 5x. All right, we know nothing. Now, we could factor it out, but again, if we do that, we know nothing's going to cancel because we've got x and x minus 5. So for our vertical asymptotes, again, it's just denominator equal to 0. Again, to work on your factoring skills. If it's x squared plus 5x, you can factor an x out of both of them. And then setting both of those equal to 0, we get x equals 0, and then x equals negative 5. Okay, for the horizontal asymptote, we've got to compare m and n. M is 1, n is 2, and to the best of my knowledge, 1 is less than 2, so that means that m is less than n. Again, go back and checking it because m is less than n. We've got a default one at y equals 0. Okay, so when we get ready for the graph on this one, good news is we've got the horizontal asymptote that is right on top of the axis, which is kind of good and kind of bad because it's hard to see it. So y equals 0 basically would be this. Okay, now we get two asymptotes. We've got one at x equals 0, so we've got one going this way. We've also got another one at negative 5. So we've got another one back here. Okay, and you may be going, all right, well, what are we going to do? Because we've got, more than one section now. Now we've got, if you look at this, basically we've got a section here and here. We went from having 4 sections, 4 choices. Now we've got 1, 2, 3, 4, 5, 6 choices to pick from. Now we're still going to do the same thing. All we're going to do is we know this value is at negative 5. We know this is at 0. So we're still just going to pick points on either side of the vertical asymptotes. So we're going to go over here and plug in x equals negative 6 and see what answer we get. Because again, it's either going to be down here somewhere or it's going to be up here somewhere. Okay, now this is where sometimes it's good to have like maybe a separate scrap piece of paper because when we start plugging numbers, it gets a little bit. So we're going to plug in negative 6. We're going to plug it into x minus 2 times x squared plus 5x. Okay, so plugging in 6, we've got negative 6 minus 2 over negative 6 squared plus 5 times negative 6. Top part's pretty easy. Just negative 6 minus 2, that's a negative 8. Bottom part, we've got 6 squared is 36. 5 times negative 6 is negative 30. That's negative 8 over 6. That is about negative 1 point. It's negative 4/3. So it's negative 1.3, repeating. Okay, but again, we're not real like, yeah, we want to know what that point is, but again, we're not superly overly concerned as long as we know where that is. If we plot this point, that's negative 1.3. So if we go back to negative 6, which would be here, we got to go down to negative 1.3, which would be about there. So if that point's there, again, now we know that graph has got to stay in this area. because it's underneath the line. It's underneath the asymptote, so it's got to stay in this area. Okay. So the longest part on these is going to be plugging in the values and working these numbers out, because now we've got to do it, a few more times, because now we've got the left side of -5. Well, now we need to go to the right side of -5 and see what's happening at -4. Question. To that part, or back up here. Okay, so now we're going to, again, so now we've gotten everything to the left side of that asymptote. We know that it's going to be in the bottom. Now we got to figure out what's going on the right side over here, because again, it's either going to be up here or it's going to be down here. And if we plug in -4, it should tell us whether that point's up here or down here. Okay, so that's what we're looking at. Again, we're going to plug in the -4. So it's -4, -4, -4. So we got, oh, sorry. Supposed to be a 5 there. So we've got -4 minus 2, -4 squared, and then plus 5 times -4. Okay, and this is kind of the tedious part on this one. If you're asking if there's a shortcut, not really. You always have to do some test points on this one. So -4 minus 2 is -6. -4 squared is 16. 5 times -4 is -20. That's -6 over -4. So that's a positive 1.5. So for that one, if we go to positive 1.5, that'll put us right about there. And again, now it's in line with this part of the graph that we're checking, because again, it could be here or it could be here. Now we know it's here, so now we know it's going to do something like this. Now, we did know that there's no holes in the graph, which is kind of good news, because if we had some holes in the graph, that means this thing could bounce through and come down this way. But there's not, so this graph should turn and go something like this. Now, just to double check, we'll plug in -1 just to make sure, because again, it should be that it's going to be up here somewhere, but we'll just double check it just to make sure. Okay, so if we plug that back in and just save us a little bit of time here, we've got -1 minus 2 over -1 squared plus 5 times -1. So -1 minus 2 is -3. -1 squared is 1. 5 minus 1 is -5. It's -3 over -4. It's not very big, but it's still positive, so that's at 0.75. So our y value is positive, so that kind of gave us the correct number we were looking for. This thing will be on that same side of the graph that we were looking at. Okay, so we know that's going to go something like that. Again, I was 99% sure of it, because again, there weren't any holes. Now, again, if we had a hole at like x equals -3, this graph could have gone through the hole, which is like a gate. And again, you could go through the gate and then come to the other side over here. But in this case, there were no holes, so this thing should have carried on to be something like that. Okay, and then finally, we get one more point, because that's 0. Let's plug in 1 and see what happens, because again, it's either going to be up here or it's going to be down here. We just need to know where that number is going to go if we plug in x equals 1. So it's y equals 1 minus 2 times 1 squared plus 5 times 1. It's -1. That's 1. That's 5. That's -1/6. Okay. And the good news with the horizontal asymptote being at y equals 0, it doesn't really matter how big or how small that number is. It's negative, so it's got to be below that horizontal asymptote, which means that graph is going to look something kind of like that. Okay, because again, that was -1/6, so it's got to be somewhere about there. Okay, so I think that's enough for today.